Hello, this is Dr. Jerry Tennant. Today I'd like to discuss with you the ability to reverse macular degeneration. I've developed a theory that retinal function is really controlled by quantum mechanics, wherein rods and cones are antennas that contain an inductance capacitance circuit that capture the frequency of light to which they're tuned. They in turn pass the digital signal to the bipolar layer that serves as transistors to create a digital image. The digital image is then transmitted to the ganglion layer and onto the brain. The voltage to maintain this circuitry is carried throughout the retina by the Mueller cells. Now, that may not make a lot of sense to you at this moment, but as we go through the presentation, it will begin to become clearer. The retina is composed of three basic layers: the photoreceptors, called rods and cones, the bipolar layer, which connects the photoreceptors to the ganglion layer, and then the ganglion cell layer, which is part of the optic nerve. Rods are designed to receive infrared light and thus can detect light and dark, whereas cones are designed to receive the frequencies associated with colors and fine detail, and is what you usually use when you are looking at things when the lights are on. Both of these serve as antennas picking up the different frequencies. The bipolar cells are transistors that assemble the images that are created by the cones in the macula or the rods in the rest of the retina. The bipolar cells then can transmit the information down the line. The ganglion cells send the electronic image that was created by a combination of the antennas, which are the rods and cones, and then the image created by the transistors of the bipolar cells, and thus then the ganglion cells can transmit these images to the retina through the optic nerve in a format that can be understood by the brain. Now, everything in the body has a wiring system in order to provide it with the appropriate voltage, and in the retina, that wiring system is called Mueller cells. They are the first cells to die in any macular disease. The choroid is the blood supply for the retina and rests behind the retina. So in this image you can see the cones that we've discussed, then the pigment epithelial layer, and behind that the choroidal blood vessels. The pigment epithelium is the mirror that reflects light back to the cones. So light comes in from the front of the eye, passes through the entire retina to the back where it hits the pigment epithelium. The light then bounces backwards into the antennas called cones. This process is necessary to help reduce non-coherent light and thus blurrier images. So to make new cells, you have to realize that the cones in the retina wear out and are replaced every 2 to 3 days. Macular degeneration occurs when you lose the ability to make new cells. Let me say that again. Macular degeneration occurs when you lose the ability to make new cells. Making new cells requires minus 50 millivolts of voltage and all the raw materials you need to make cells, namely amino acids, cholesterol, fats, vitamins, and minerals. The brain and retina are 50% cholesterol by weight, so your liver must be able to make cholesterol to heal the retina. You must also eliminate poisons that damage the new cells, like dental infections. The first thing that happens when you start to develop macular degeneration is loss of voltage in the wiring system, namely the Mueller cells, and in the blood supply, which is the choroid. Loss of voltage causes loss of oxygen. The amount of oxygen that will dissolve in water is dictated by the voltage of the water, and since cells are 70% water, the amount of oxygen that's available is dictated by the voltage. In this image, you see again the cones and the choroid. As oxygen levels begin to drop, when voltage drops, you begin to get clumping of the pigment epithelium in the epithelial layer, as you see in this diagram. And if you just simply look at the retina, you begin to see these little brown dots that are clumped pigment cells. The next thing you get are scars. These scars are called drusen. You see, as you look in the back of the eye, they look like little yellow waxy spots, and in a histology cross-section, you see these deposits that are a mixture of calcium, cholesterol, and fibrous tissue. Namely, they are scars. You can also see in this image how the drusen distort the cones or the antennas, making it more difficult for them to pick up images. And this distortion causes letters and images to appear distorted, as you see in this test called the Amsler grid. When you look at this grid with a normal eye, all of the squares are the same size and the lines are straight. But as you began to develop drusen and distortion of the retina, you began to see these lines and squares become distorted. This is one of the earliest signs that you're developing macular degeneration. As voltage and oxygen levels drop, new blood vessels grow from the choroid in an attempt to keep the retina nourished. This is called wet macular degeneration. Bleeding into the retina in wet macular degeneration is caused by low voltage and low oxygen. Anytime in any tissue there is low oxygen, the body will create new blood vessels to grow in an effort to provide adequate oxygen to that tissue. These new blood vessels can bleed into the retina, and all of the inflammation caused by this bleeding eventually causes scarring and permanent loss of vision.
Age-related macular degeneration. The macula is a